A Soviet Predator, a Fulcrum, flying Kalashnikov, and a fighter of war over its own airfield. One of the most controversial fourth-generation fighters, gathering both rave reviews and angry criticism. Hello aviators, Sky here, and today we'll be getting to know an aircraft that has undergone many maneuvers in its life. I present to you the great and terrible MiG-29. In the 1960s, the spirit of the fourth generation of fighters was in the air. The passion for high-speed missile skirmish began to give way to a new trend, a passion for missile skirmish in maneuverable combat. Furthermore, well-equipped and armed machines could now not only conduct fast raids, but also stay in the air longer, controlling larger areas. The concept of air superiority began to take shape. But these trends came at a price. Aircraft became increasingly complex and expensive, and the military began to reduce the number of specialized aircraft types in favor of fewer multi-role ones. The United States began addressing this issue back in the early 1960s, and the Pentagon actively lobbied for the idea of a single fighter with broad capabilities, and modifications for several branches of the military. Yes, the JSF program had a predecessor, the TFX program, which evolved into the F-111. At that time, the USSR was essentially doing the same thing. The first requirements for the concept of a unified prospective frontline fighter, or PFI, were formulated in 1971. According to the military, the new aircraft was to have a high thrust-to-weight ratio and maneuverability, carry effective equipment and weapons, be capable of long and close-range air combat, and attack ground targets. It had to be effective around the clock in any weather conditions. At least it wouldn't have to fly into space, thanks for that. The PFI program was led by three aviation centers: the Mikoyan and Gurevich, Yakovlev, and Sukhoi. The MiG Design Bureau conducted the project under the designation Subject 9. If you think that Subject 9 doesn't quite resemble our hero, I agree. Initially, engineers leaned towards proven configurations like the MiG-31, which were quite relevant and well established. They were reluctant to implement avant-garde designs, too many risks. In 1972, the projects of three bureaus were presented to the Air Force Command: Mikoyan's Subject 9, Sukhoi's T-10, as well as Yakovlev's Yak-45 and Yak-47. The leaders of the race were the Sukhoi and MiG projects. However, by that time, the idea of a single multi-role fighter was being abandoned. After rereading the requirements, someone began to suspect that it wouldn't be possible to implement everything in a single aircraft. And even if it were, it was highly questionable how effective such a multitasker would be. Incidentally, the idea of a single aircraft in the US also failed to materialize, and was spun off into several different projects, which eventually evolved into a team of teenagers. So, instead of a single aircraft, it was decided to create two, dividing the roles between them. The Sukhoi Design Bureau was assigned the PFI, and the MiG Design Bureau was assigned the LFI, Light Frontline Fighter. Usually, the LFI is described simply as the PFI's little brother, essentially the same fighter, just smaller. But to better understand the motives behind many of the subsequent decisions, I think it's worth digging a little deeper. A fighter jet isn't a thing in itself, and is initially created as part of a system within a specific strategy. This strategy dates back to the height of the Cold War, when Europe was the main theater of potential conflict between two military alliances, and where the LFI had its role. The USSR and the Warsaw Pact countries built a vast network of airfields along their western borders, often located close to one another. Fighters relying on this network were supposed to form a continuous air front, taking off, engaging, and returning, often jumping from base to base, which provided both operational flexibility and backup. Every base was a potential target for bombing, including nuclear. This meant that the LFIs had to maintain high readiness and engage in combat as quickly as possible. Range, however, was not critical. The main thing was that, after combat, they could return to one of these airfields in a given region, or even operate from poorly prepared airstrips or roads. Naturally, to ensure the density of this front, the LFI needed a corresponding number. According to initial plans, 70% of the Air Force's fighter fleet was to be comprised of the LFIs. Of course, no one expected the fourth-generation fighter to be churned out in the thousands like the MiG-21, but there still had to be a lot of them, so the aircraft had to be inexpensive. Again, given the potential numbers of participants on both sides, the clashes promised to be quite intense, with frequent transitions to close-range combat, practically a dogfight, wall-on-wall. Thus, the LFIs were required to have the best performance for combat at medium and especially close ranges, maneuverability, thrust-to-weight ratio, and all the necessary equipment and weapons. Oh, and they didn't forget about versatility either. The LFI was a team player, designed not only to fight anyone, but also to support its allies. This included everything from bombers and heavy fighters to attack aircraft and helicopters, as well as ground forces, both protecting them from air attacks and striking ground targets. It wasn't intended to be an attack aircraft or a bomber, but given its numbers, the LFI could provide valuable support. And having taken on the LFI with all these requirements, Mikoyan's team faced a problem. Extensive functionality and high performance now needed to be integrated into a compact and lightweight aircraft. Every pound and inch would have to be fought for. It was clear that the old layout was insufficiently effective. Something different was needed, and everyone knew what it was. The integral scheme, or lifting body, with a monolithic airframe in which all elements seem to flow into one another, promised a significant improvement in aerodynamics, sufficient to meet the requirements. The downside was that it was the very same avant-garde, barely studied and highly risky. But the Mikoyan team decided to take this risk. After exploring numerous options, the Design Bureau finally arrived at the form we are familiar with. The 12th iteration of Subject 9 was adopted as the basis, and the project became known simply as 912. The key issue in the design was the choice of power plant. Single engine or twin engine. At first glance, a single engine seemed optimal, especially since it already existed, the AL-31F, which was developed for the Su-27. However, experience with single-engine aircraft, which was quite controversial in the 1970s, played a role. Engines were unreliable, and failure of a single engine often meant the pilot would have to return to the ground on a parachute. Previously, when aircraft were cheap and mass-produced, this was tolerable, but the fourth generation would be much more expensive, and such losses were unacceptable. And in combat conditions, no one could guarantee that a single engine would cope with the high thrust-to-weight ratio requirements, especially since the AL-31F was just being born, and with great difficulty. So, after much debate, the twin-engine option was chosen. The need for a new engine, compact and lightweight, immediately arose. Its creation was taken on by engineers from Klimov's Design Bureau. Thus began the birth of the fiery heart for the future MiG, the RD-33. In 1974, a government decree was issued on the creation of the fourth-generation light frontline fighter. The LFI 912 finally officially became the MiG-29. Having barely received the order, the Bureau encountered the customer's impatience. The military wanted the fighter as soon as possible, so it was decided to develop the aircraft in two stages. First, the MiG-29A, a simplified version with a new airframe and engines, but with previous generation equipment, primarily from the MiG-23. Later, the fully fledged MiG-29 with new generation onboard systems was to be developed. But an event intervened in this beautiful plan. In 1976, the MiG-25 Interceptor was hijacked, taken to Japan, and thoroughly studied by American engineers. The project was caught in the crossfire. The entire MiG-25 fleet had to be essentially rebuilt, while simultaneously accelerating the MiG-31 project. This work consumed all efforts, and there weren't enough hands for the newcomer. Under these circumstances, it was decided to abandon the early MiG-29A and concentrate scarce resources on the main project. The result of this concentration was evident on October 6, 1977, when the MiG-29, tail number 901, made its maiden flight. The testing program was extensive, involving 14 prototypes and several flying labs. They flew actively, often delighting their creators with outstanding performance, and just as often requiring modifications, which makes for quite distant differences between the early versions of the aircraft. In parallel with the single-seat fighter, a two-seater was also being developed, the MiG-29 trainer with an enlarged canopy but without a radar. There was not enough space in the nose. The main problem arose with the engines. The RD-33 were crude and capricious, leading to the loss of two aircraft, and their fuel consumption was excessive. And yes, they smoked, a family trait of the combustion chamber in certain flight modes. The final prototype, complete with all modifications, was Aircraft 925. It can be considered the father of all production aircraft. The MiG-29 entered service in 1983. Production began at the Moscow facilities, the cradle of the MiG-21. The MiG-29 entered production in 1985 at the Gorky aircraft plant, the birthplace of the MiG-25 and MiG-31. Well, now that we have a finished MiG-29, let's take a closer look. Overall length 17.32 meters, wingspan 11.36 meters, height 4.73 meters. Quite compact and at the same time with a funny optical illusion. The similarity in the layout of the MiG-29 and Su-27 makes many people think they are almost identical, just slightly different in dimensions. But when you put the aircraft side by side, you immediately realize how different these dimensions are. Integral scheme. The fuselage here is not easy to define, with lift generated by a virtually solid body, the fuselage, leading-edge extensions, and the wing. The high-lift devices are classic, 3-section leading-edge slats and slotted flaps, plus ailerons. The tail consists of a pair of all-moving stabilizers and a pair of large, slightly inclined fins. The tricycle landing gear is quite robust, making it rather undemanding on runways. The nose leg has 2 wheels, while the main landing gear legs are single wheel. The results of the weight-saving campaign are difficult to discern externally, but they are evident internally. The aircraft is assembled primarily from large components and panels, reducing the number of joints, while internal components bear some of the load. For example, the core of the MiG's structural design is the central fuel tank, which is welded from steel. Good thing they learned how to make such parts back on the MiG-25. Composites were also used, albeit sparingly, as the technology was still in its infancy. The engines are located in the tail, but not pressed together like on many similar aircraft. Instead, they are slightly spaced apart with a spine, a fairing from the cockpit to the tail filled with equipment, ending with a braking parachute assembly. Also located here in the space between the nozzles is the aerodynamic brake, 2 panels splitting vertically. The engines themselves are a pair of RD-33s. They are low bypass turbofans with an afterburner, variable nozzles, and hybrid electronic-mechanical controls. The RD-33's unique feature is that, due to its small size, it has quite a wide range of controls and responds quickly to thrust levers commands. Furthermore, it can operate reliably in extreme conditions at various altitudes and speeds, and during virtually any maneuver, even when the aircraft is flying tail first. Thrust varies between 11,110 pounds-force in normal mode and 18,340 pounds-force in afterburner mode. Meanwhile, it's noticeably more compact than the AL-31F and almost 50% lighter. In fact, just looking at the bare engine, it's surprising how small it is. The MiG's wedge-shaped air intakes are positioned downward under the fuselage. This layout minimizes the risk of airflow obstruction during maneuvering. Dynamic panels are located inside the intakes, forming optimal airflow at all flight modes and speeds. However, on the ground, such a low position actually increases the risk of foreign objects being sucked in. This problem was solved radically. During takeoff and landing, the main ducts are covered with protective panels, and air enters through a kind of gills on the top in the leading-edge extensions. In flight, this entire system returns to normal operation. Most of the remaining fuselage space is occupied by the fuel system, 5 tanks plus 2 more in the wing consoles. They hold approximately 7,700 pounds of jet fuel. A special external tank holding approximately 2,650 pounds was also designed for the plane, mounted between the air intake ducts. By the way, when designing the entire system, the MiGs creators didn't forget about ensuring high combat readiness in terms of ease and speed of maintenance. The aircraft itself was robust and featured a high number of hatches and cowlings, providing easy access to all onboard systems, while the engines were assembled in such a way that they could be quickly replaced. This may seem standard practice now, but for the technicians of the time it was a real blessing, as they were accustomed to things like the MiG-23, whose engine replacement required disassembling half the aircraft. All this gave the 29th yet another nickname, the Flying Kalashnikov, which it easily inherited from the MiG-21. Usually, when discussing combat aircraft, we describe their flight performance without focusing on boring instruments. But fourth-generation fighters marked the point where all these boring instruments became at least as important as speed and thrust. And for engineers, this presented an extremely challenging task. They needed to give this small aircraft capabilities previously available only to its much larger counterparts. The controls were more or less classic, mechanical with power assist. The fly-by-wire system was very promising, but in the 1970s it still seemed a bit crude, and the military themselves, being conservative, looked with suspicion on little motors connected to a computer. Especially since, even without it, the aircraft was full of cutting-edge equipment, from the autopilot to the weapons control system, and all of it required attention. The aircraft's main eye is the NO-19 Rubin, a new generation radar capable of detecting a fighter at a distance of 30 to 40 miles, tracking up to 10 targets simultaneously and engaging 2. The second eye was the Quantum Infrared Search and Track system, the head of which was located in front of the cockpit. It could detect a fighter at a range of 8 miles and lock onto it at 5 miles. How was it quantum? I don't know, probably because of the rangefinder, laser and therefore quantum, and the engineer's slight zeal for showing off, a kind of Soviet marketing. But even without that, it's safe to say that not every fourth-generation fighter was equipped with integrated IRST, so that in itself is pretty cool. The pilot was seated in a raised cockpit and enclosed in a teardrop-shaped canopy with wide glazing for optimal visibility. The ejection seat was the K-36DM, which appeared on the MiG-31 and became popular among Soviet jets. The cockpit's equipment was fairly classic and, for the most part, analog. But it wasn't without special features. The pilot was given a helmet-mounted targeting system, allowing him to aim missiles in close combat simply by turning his head towards the target. Such instruments are common today, but in the 1970s they were pure cyberpunk, making the fighter even more dangerous in a dogfight. And of course, a next-generation combat aircraft needs lots of weapons, also next generation. The MiG-29 received 7 hardpoints, 6 under the wing and 1 between the air intake ducts for a drop tank, capable of carrying up to 2 tons of payload. Given that short-range missiles were intended for close, maneuverable combat, they needed to be given the appropriate parameters. This resulted in the R-73 or AA-11 Archer missile, with an all-aspect IR warhead and control of both wings and the thrust vector. Firing range 16 to 20 miles. Another brand new missile, the R-27 or AA-10 Alamo, was responsible for medium-range combat at about 40 to 50 miles. It comprised a whole family of different modifications with varying ranges and homings, infrared and radar. Air-to-air combat was initially limited to this. There was no point in installing long-range missiles here. They didn't fit the concept, and the radar wouldn't have allowed their effective use anyway. To communicate with those crawling on the ground, a full set of toys was attached to the plane, including aerial bombs and rockets, at that point still unguided. The crude weapon is the Gryazev-Shipunov 30mm single-barrel cannon, also known as the Gesha 30-1, which was mounted on the left leading-edge extension. The new cannon proved popular, being installed on the MiG-29 and Su-27, as well as their successors, including the Su-57. Its rate of fire is 1,800 rounds per minute, and its ammunition capacity is 150 rounds, a full salvo in 5 seconds. Flight performance. Maximum speed Mach 2.3, 1,320 knots. Service ceiling 59,000 feet. Very good. The engineer's greatest pride, the aircraft's integral design with its solid lifting airframe, performed admirably. Moreover, the structure proved so robust that it could perform 9G maneuvers without limits, with any weight and in any format, the only limitation being the human ability to withstand such stress. Add to this the excellent thrust and responsiveness of the engines, and voila! The MiG-29 performed aerobatics in the air that pilots could never have dreamed of, and it could only be put into a stall by force. Interestingly, the most maneuverable variant turned out to be not the original fighter, as many might expect, but the two-seat MiG-29UB. Apparently, removing some of the heavy equipment, including the radar, made it even more nimble. But the weight characteristics weren't very good. The dry weight of an empty aircraft was 10.9 tons, 24,000 pounds, with a normal takeoff weight of 15.4 tons and a maximum of 18.1 tons, 39,900 pounds. There was a bit too much metal, robbing a couple of tons off the payload of weapons and fuel, which impacted its range. At ground level, the aircraft could fly 380 miles, at high altitude 760 miles, and with a drop tank 1,130 miles. Such modest figures earned the aircraft the nickname Air Superiority Fighter over its own airfield. Although the concept of its use did not envisage a large combat radius, a small increase in it in the future was, let's say, highly desirable. Actually, this was undertaken immediately after the original aircraft entered serial production, with the goal of improving not only its range, but also its functionality. The war in Afghanistan was raging in the south, where the Mujahideen suddenly acquired Stingers, making defense measures a priority. The aircraft received electronic countermeasure systems and flares. Meanwhile, the fuel system was optimized, allowing for the use of under-wing drop tanks. Ultimately, the MiG gained additional features, but its range remained virtually unchanged. It was eventually extended to 1,560 miles, but only by mounting 3 fuel tanks, which prevented the aircraft from flying supersonic. This is how the MiG-29 version 913 appeared. Okay, time to enter service. The first to master the new fighter were pilots based at Kubinka Air Base near Moscow. They had it easier in this regard. The elite Guards Regiment had already become familiar with the MiG-29 and Su-27 during the testing phase. In fact, the first MiG-29 team specializing in demonstration flights was formed there in 1991. This is how the Swift's aerobatic team was born. All this time, the MiG-29 was actively deployed to other Soviet training centers and air bases, including the Mari-1 Air Base in Turkmenistan, the Air Force Training Center where they simulated combat with enemy aircraft. Yes, their own aggressor squadron and the Soviet Top Gun. And keeping with long-standing tradition, a MiG-29 was also hijacked. In 1989, one of the jets based in Georgia flew to Turkey. However, this time, diplomats responded quickly and the aircraft was returned the next day, without the pilot. By the late 1980s, the Soviet Air Force, Air Defense Force, and Navy had approximately 800 MiG-29 fighters in service. In keeping with the Frontline Fighter concept, most of them were deployed in regions bordering NATO, Eastern Europe, and the Western USSR. The CIA, naturally, hasn't been idle all this time. As early as 1977, they discovered 2 unusual aircraft in images of Ramenskaya airfield, which they designated Ram-L and Ram-K. Several years later, after receiving more details, they were assigned NATO designations: Fulcrum for the MiG-29 and Flanker for the Su-27. The world saw the MiG-29 in 1986, when the fighters arrived in Finland with the Soviet delegation.
The first of two MiG-29s, the latest and most sophisticated of Soviet warplanes, crossing the British coast shortly after 2 o'clock. The first Soviet fighters ever to do so. A friendly reception provided by the RAF. Then a historic landing to claim their place as undisputed stars of the forthcoming Farnborough show, which starts at the weekend.
In 1988, the aircraft was unveiled to the public at the Farnborough Airshow, where it demonstrated its capabilities brilliantly, performing complex aerobatic maneuvers, some of which had previously been impossible for jet aircraft. In 1989, at the Paris Airshow, there was a live demonstration of the K-36 ejection seat. During the MiG-29 flight, one of the engines failed due to a bird strike. The aircraft, flying at minimum speed and altitude, failed to react and crashed almost immediately. Although without casualties, the pilot ejected at an altitude of less than 300 feet, quite safely. The K-36 seat proved its worth again at the Fairford Airshow in England in 1993. During a paired maneuver, two MiGs collided, and even in what was, to put it mildly, an extreme situation, both pilots ejected successfully. Journalists then remarked that they jumped out from under the coffin's lid. But while the MiGs were dazzling everyone at air shows, they were facing challenges in service. Criticism was leveled at the occasionally weak onboard systems, the engines were fuel-hungry and short-lived, and of course the range was insufficient. Even then, the concept of close-range combat was losing favor, and the military wanted a longer-range, more versatile aircraft. And now the designers had a chance to give their project new impetus. In the 1980s, the Soviet Navy began developing fully-fledged aircraft carriers, which would carry the naval versions of the Su-27 and MiG-29. The Su-27K, being heavier and longer range, served as a fighter interceptor, while the MiG-29K was planned to be more multi-role, including engagements with surface targets. This is somewhat similar to the pairing in the US Navy at the time. The F-A-18 served as an attack aircraft, while the F-14 was designed to ride into the danger zone. Having received the order, the Design Bureau launched a large-scale project, which included creating not only the naval MiG-29K, but also its land-based brother, which was supposed to solve all the problems of the original, the MiG-29M. And they undertook extensive work. The leading-edge extensions, wings, stabilizers, and the air brake were redesigned. Engineers replaced the air intake protective panels with mesh and removed the upper gills. They also optimized production methods, which led to a reconfiguration of the internal components and an increase in fuel capacity. Materials were also updated, with lightweight aluminum-lithium alloys and composites being used. Interestingly, even then, Mikoyan's team began toying with radar stealth, although not as fanatically as their colleagues at Lockheed, limiting themselves to testing radar-absorbing paints, which later gained some popularity among fourth-generation fighters. The engine also underwent a major overhaul, so much so that the updated RD-33K received its own internal designation. The old version was named Izdelye 88, while the new one became Izdelye 21. The engine received electronic controls, an additional compressor stage, and redesigned combustion and afterburner chambers, the source of the main problems, including smoke. Thanks to this, the engine became more reliable and fuel-efficient, while simultaneously increasing thrust to 11,900 pounds-force in normal mode and 19,400 pounds-force with afterburner. New engine performance and a parallel increase in fuel reserves yielded one of the key results. The flight range at high altitudes reached 1,100 miles, and with external tanks, 1,600 miles. Not bad. The filling was changed even more radically. The aircraft got its fly-by-wire controls, and many systems were replaced with new ones. The new NO-10 Zhuk radar now had a range of 50 miles, could track 10 targets and engage 4, and it also performed much better on both land and sea surfaces. The cockpit was also improved, with a new head-up display indication and screens. Combat load increased to 4.5 tons, and 2 additional hardpoints were added to each wing console. The R-77 or AA-12 Adder missile, with a range of up to 50 miles and a fire-and-forget active radar homing, was added to the arsenal of air-to-air arrows. And most importantly, the MiGs learned to use precision air-to-surface weapons, guided bombs and missiles. All these solutions were implemented simultaneously in both the M and K versions. Meanwhile, the naval version also had its own unique features. Corrosion protection, reinforced landing gear, a landing hook, folding wings, slightly different high-lift devices, and of course an in-flight refueling system. Furthermore, its engines had a special emergency mode, allowing for a short-term output of 20,700 pounds force in afterburner. Testing began in the mid-1980s. Initially, solutions were tested on existing aircraft, followed by full-scale prototypes. The MiG-29M made its maiden flight on April 26, 1986, although that day went down in history for another reason. While aviation scientists were celebrating something wonderful, rumors began to appear that something terrible had happened to the nuclear scientists. Misfortune didn't come alone. The project was dealt a blow by a spy scandal, when it was revealed that in one of the key centers developing onboard equipment, there was a CIA agent. The MiG-29, along with the MiG-31, were compromised. As with the MiG-25 hijacking, everyone rushed to redesign their aircraft systems, and this time, the work resulted in the modernized MiG-29S. All this time, the MiG-29M was being tested on the ground, and the MiG-29K on an aircraft carrier. But due to the complexity of the systems and spy investigations, the work was being delayed. No one thought it was a problem. Success was already within reach. It seemed that in just a couple of years, the new machine would rise and conquer the world. But they didn't have a couple of years. In November 1989, the Berlin Wall fell, marking the end of the Cold War. Soon, the Warsaw Pact began to crumble, followed by the Soviet Union itself. These events broke the MiG-29 at a conceptual level. The idea of large groups of light fighters, based on a dense network of airfields along the front line, lost its relevance. The Cold War ended, and no potential front line was in sight. Most importantly, almost the entire airfield network was located abroad. Within Russia itself, bases were scattered across a vast territory, and the small groups remaining in the country, numbering approximately 400 aircraft, were cut off from each other by distances too great for them to form a unified force. But other advantages have also become less relevant. The MiG-29 can still be considered one of the best in close combat, capable of outmaneuvering and defeating almost any opponent. But over the past decades, aviation has changed technically and tactically. Air combat is not a one-on-one duel. A spectacular dogfight is mostly a plot of a movie. In real life, air combat is a clash of entire systems, which, in addition to fighters, light and heavy, include electronic warfare aircraft, flying radars, ground support, and space reconnaissance. Deprived of such a system, a close combat fighter turns into a pride samurai, fearlessly charging into machine guns. In fact, an example of such a situation was not long in coming when Operation Desert Storm began in 1991. Finding itself in the motley and fragmented Iraqi Air Force, 36 MiG-29s were no match for the US Air Force, which spotted and shot down Iraqi aircraft, often before they could even engage. The MiGs could be defended here by arguing that the enemy had overwhelming superiority, and from the onset, minimal chances of success. But in any case, such results clearly did not help the fighter's reputation. The Ministry of Defense of the new Russia, facing a severe budget crisis, lost the ability to purchase fighter jets on the same scale as before, and was forced to choose which of its aircraft to prioritize. And so, the Su-27 found itself in a position of the golden boy. It was more multi-role, covered a wide range of missions, and could engage not only at short and medium ranges, but also at longer ones. Moreover, given its range, it wasn't as dependent on the airfield network. And while the MiG-29 required support of heavy fighters, the Su-27 could operate independently. Yes, it was more complex and more expensive, but its advantages outweighed these differences. The MiG-29M, which could have solved many of the original fighter's problems and made it far more competitive, was too late. Its refinement and launch into production required time and money that were no longer available. Ultimately, the military made its choice: the flanker. Purchases of light fighters dropped to almost zero, and without orders and funding, the MiG-29M and MiG-29K programs effectively ceased. A similar situation unfolded not only within Russia, but also on the international market. The USSR envisioned the MiG-29 as its primary export fighter and sold it quite successfully. The first deliveries began in 1986 to India, and by the early 1990s, around 300 aircraft had already been delivered to the air forces of 12 countries. But in the context of purely commercial competition, the aircraft faced another problem, one that hadn't been particularly considered before. What niche did it serve? The question seems odd at first glance. Any school kid knows about the eternal opposition between the MiG-29 and the F-16. However, when you start comparing the two, it becomes less obvious. For example, the F-16C's empty weight, without weapons or fuel, is approximately 18,900 pounds. The MiG-29C weighs a whopping 24,700 pounds, a significant amount for a light aircraft. In fact, it's heavier than medium fighters like the F-A-18 and Rafale. However, the MiG can't really be considered a full-fledged medium fighter, as it is inferior to representatives of this class in maximum weight, combat load, and range. In other words, it's neither light nor medium. There are many reasons for this situation. All these structural reinforcements to withstand high G-forces, a powerful landing gear, and integrated systems are far from weightless. But the main reason, of course, is the twin-engine power plant. It's heavier and less fuel efficient. Many criticize this decision, believing that if the aircraft had been equipped with a single AL-31F, unified with the Su-27 engines, the situation might have been different. In fact, that's how the F-15 and F-16 paired together. Even today, we know of many successful single-engine fighters. The American F-16, the Swedish Jas-39, and even the Chinese J-10, which is equipped with the same AL-31. On the one hand, all these arguments are compelling, but on the other, we remember the concept for which the MiG was developed: close-range maneuverable air combat and consequently high thrust-to-weight ratio and flexibility, something a single engine might not even be able to handle. Besides, all these successful examples are familiar to us now, but in the 1970s, the F-16's prospects were unclear. Its competitor, the twin-engine YF-17, was the favorite, and the Swedish and Chinese jets weren't even planned yet. As a result, even on the foreign market, the Su-27 began to attract more attention. A perfectly clear, heavy, and powerful fighter, and ambitious countries willing to pay for this power began to emerge among the customers. The MiG found itself in a difficult situation. The aircraft continued to enjoy export demand and required fleet maintenance, which ensured continued operations. But this demand was modest, and so too were the projects. The aircraft continued to be improved. The MiG-29 SM modification appeared, expanding the capabilities to carry high-precision air-to-surface weapons, and then the MiG-29 SMT, with updated equipment and additional fuel tanks behind the cockpit, giving it a slight hump. Along with these, updated two-seat versions appeared, such as the MiG-29 UBT. The initially maneuverable fighter, of course, didn't miss the chance to experiment with super maneuverability. Thus, in the early 2000s, the world saw a modification of the MiG-29 with perhaps the most striking thrust vector mechanism, an all-directional metal flower. The MiG-29 OVT was a true star of air shows back then, performing absolutely insane maneuvers in the air that no other aircraft could replicate. However, the demonstrator remained just that, a demonstrator. The flower was too complex for mass production, and the concept of super maneuverability thanks to a dynamic nozzle was implemented on a more modest scale. Finally, by the early 2000s, engineers were able to move beyond interim improvements to a full-fledged model update. The MiG-29M and MiG-29K projects were relaunched. The Indian Navy was looking for a carrier-based fighter for their own first aircraft carrier, the Vikramaditya. while the Russian Navy once again wanted to supplement the Su-33, heir to the Su-27K on the Admiral Kuznetsov. Frankly, the MiG-29 is at its most effective on an aircraft carrier, where many of its features, such as its twin-engine configuration, are still fully justified. Again, I've already compared the MiG to the F-A-18 and Rafale, and yes, both were designed with carrier-based aviation in mind. While externally similar to their late 1980s predecessors, the new aircraft's filling was once again significantly redesigned. They received an updated RD-33MK engine, with afterburner boosted to 19,900 pounds force, a fully functional fly-by-wire system, and the new Zhuk radar, the top-end versions of which were equipped with an active electronically scanned array. The MiG-29K and its combat training version, the MiG-29K UB, entered production. A couple dozen were received by the Russian Navy, and another 45 were sent to India. The history of the MiG-29M was more complex. Initially, the project produced the M and M2 fighter versions, single-seat and two-seat, and sometime later, with another wave of improvements, the MiG-35 was born. Ideologically, it can be considered a full-fledged second generation of the MiG-29, much like the F-A-18EF Super Hornet is an updated generation of the original F-A-18CD Hornet. And the MiG-35, being barely born, was immediately embroiled in the ultimate aviation Santa Barbara of the early 21st century, the medium multirole combat aircraft tender, under which the Indian Air Force planned to purchase a whopping 126 fighters. The Yas-39, F-16, Fa-18, Eurofighter Typhoon, Rafale, and the MiG-35 all competed in this beauty contest. The Indian show was epic and slightly tedious. After nearly a decade of testing, showdowns, and scandals, the Rafale was declared the winner. One could argue at length about why the MiG-35 lost, whether its performance wasn't up to par, or whether India simply didn't want to run into the monopoly of Russian exporters, with Sukhoi already reigning supreme in the heavy fighter niche. In any case, it was a serious blow to the MiG. Having lost its landmark order, the 35 found itself out of business once again. Of course, the Russian airspace forces ordered it, but in a purely homeopathic dose, just a few units. The military had already become accustomed to the Su-27 and the flock of its relatives. And now, the MiG has begun to lose another advantage, its low cost compared to its peers. Small production scales increased expenses, and new low-cost competitors such as the J-10 and JF-17 have entered the market, already enjoying demand among developing countries. A total of approximately 1,600 MiG-29 fighters of all versions have been produced to date. Hundreds of them continue to serve in numerous countries. The largest operator is obviously Russia, with about 100 aircraft in its service, not counting the reserve fleet. Around 80 aircraft fly in India, about 40 in Egypt, and small flocks are scattered throughout the fleets of a couple dozen other countries. The US also has MiG-29s. After German reunification, East German Air Force MiGs fell into the hands of NATO engineers and aviators, who didn't hold back with their curiosity, studying the aircraft on the ground and in the air, including staging mock battles. And yes, the MiG, true to its maneuverability concept, was inferior in long-range combat, but in close combat, it gave its colleagues a run for their money. The MiG-29 first arrived in America itself in 1997, when the US purchased 21 aircraft from Moldova, thwarting Iran's attempt to buy the planes for themselves. There, the MiGs were studied and used for training flights. However, this practice didn't last long, and most of the aircraft have now been scrapped, sent to museums, and purchased by private owners. Many people can afford a beautiful business jet, but not every kid can take a real Russian jet fighter for a ride on a weekend. The MiG-29's history turned out dramatic. It was a fairly successful aircraft at the end of the Cold War, becoming one of the symbols of Soviet aviation. But tectonic political shifts cut the ground from under it, and in the 1990s it was unable to compete openly with its counterparts. But the story of its creators is even more dramatic. The legendary Design Bureau, struggling to survive for all these years, was losing resources. As a result, the military's choice of Sukhoi fighters 25 years ago has been repeated today. In the 5th generation of Russian fighters, we see a pair of cutting-edge birds, and both of them have the Su designations. Whether we'll ever see a new MiG on the list of future aircraft remains an open question. Like and subscribe to the channel to stay up to date with the fighter jet epic. Fast flights on cool planes, and soft landings to you.